Okay, this is Physics 221 lab, the experiment on rotational motion rolling objects. Now we're only going to use one object in this lab, and that is going to be a cylindrical shell as is drawn right here. Now we have a rolling object down a ramp, an inclined plane. And we're going to do two things here is our goals. Is to predict the final velocity using conservation of mechanical energy and try to calculate an experimental velocity using the t, the time, which is the t in this phrase, and the h and the x, using a stopwatch to try to have an experimental value and again compare it to a theoretical value. Now as the object rolls down the incline, since it's rolling, we have our initial velocity and our initial is zero, and our initial potential energy is maximum there, mgh, gravitational potential energy. And as it rolls down the incline, its kinetic energy increases as its potential energy decreases. But since it's rolling, we have two types of motion. So our kinetic energy is in two forms. 1/2 mv squared, the translational kinetic energy, that's the object moving on the incline, and rotational kinetic energy, that's the object rotating. So I is the moment of inertia, omega is going to be your angular velocity, and we are going to use the moment of inertia of a ring, I ring equals mr squared, conservation of mechanical energy, to predict our final velocity. So we have to solve this equation right here for v. And that's what we have here, almost. There is the final result of that. So we notice that radius and mass cancels. So as it says in the lab, do we even need to measure the radius or mass of our object that we are rotating? Now here is our experimental final velocity as I briefly showed you before. And now we're going to do a trial run on this experiment. So we have a ramp which is at a slight incline, stopwatch, and our cylindrical shell as we saw. So we're going to hit this stopwatch now, and let's go ahead and do it. Okay, now our x is the distance that we measured from the tape to the end of the ramp as 1 meter, just to make it easier on our calculations. And it looks like we got a time here of 2.02 seconds. Now he's measuring the height here, but we have to measure it from the bottom of the ramp.
6 centimeters.
6 centimeters to the bottom of the ramp. We can't measure it to the top of the ramp because then we have to subtract this distance here. And that is our experiment. So let's go. Hopefully we can, you guys can do a good job in doing the theoretical and experimental calculations based on the time, and we will have to do several trials. Thank you.